Nathan, if you like to start, I already started the live stream. I think you're muted.
Okay. Good morning, everyone, or good afternoon, good evening, good night. I don't know when you're watching this or where. Today we're going to talk about ArcGIS, which is another software to perform spatial analysis and other type of geographical information analysis. This one, it will be a little bit different than we have been learning in the last two or three sections. And the main difference here is that ArcGIS is a paid software. So this one we won't be able to download together because for us to be able to download it, we need to um, uh, log in and then you're going to see my password and I'm not going to do that. Um, but some universities do have a contract with ArcGIS. So Duke offers students and employees I think employees as well. I'm not sure about that, but I think yeah, employees as well. The license to download the ArcGIS. So I'm going to show you how it works and how we can perform the same things that we did in the other software, the QGIS. So let me share my screen. So here we have the website. This is for ArcGIS Online. As you can see here, we can sign in and then it'll give us this one, my password. Let me see if I can go here. So you have your own domain. Okay. So as you can see here, there's my own domain and it's through here that I can download the app or the software. So I pay from my own pocket, my own expense. Um, and it's not that much when you use the student one, but it can be very expensive for low and middle income countries because it's in dollars. So we need to come here and then download it, and after that we can actually open the app, the software, and it will be like this. So as you can see here, there's my name on it because I need to, once I open it, input my login information again. So that's how we can perform the analysis. We need an account and we need it to be paid prior to download it and then to using it. But it's a good software. It's one of the probably the best software that we have, the best GIS software that we have. And it reminds a little bit more of a Office, like Microsoft Word type of performance, but it's very intuitive on how to perform the things. Some are not, but most of them are. So once you open this, you have a new project that you can open, like a map, a catalog, a global scene, a local scene, or we can start without a template. Recent projects will be here. I don't have any because I am opening this for the first time after my computer crashed a little bit ago. So I don't have any recent projects here. So let's start with a map. You don't need to click twice, just once. Then you can name what the project will be. I'm gonna put Spatial Analysis 101, ArcGIS Session 1. Then you wait a little bit. And it opens something like this. So this is the standard. It's creating something. It is very time consuming because it will load every single thing that you do. It will load again and then load everything again and then load everything again. So be mindful of this because sometimes it's gonna take a while to perform the analysis. Let me just here so I can see things. Okay, so this is the basic. This is the standard. How when you open it, as you can see, we already have a map here. So I can move it around, and we're gonna see all the road. We can zoom out. So this is a projection that is basic from the Esri, because the company that created ArcGIS. Does someone remember which projection is this one?
The one that makes the poles look bigger than they are.
Yes, the name.
I could guess.
This is the one that it's the standard for almost everything.
Mercator? No.
Mercator, yes. So the Mercator one is the one that distorts everything around the poles. So Antarctica appears very big, and then Greenland appears very big. Russia, Canada, they are big, but not that big. And then around the center on the equator, it's a little bit more close to real. So this is the basic. So this is the standard. We can zoom in, and it's gonna be. I chose the perfect city. And then we can just like come here and zoom in, and we're gonna put you're gonna expand the map. So I can choose to not show it, the topographic map. So I only have the hue shade, or I can have removed the hue shade and stick with the topographic map, or none of them. One thing that I would like you to see is that let's stick with the United States here. And then I will input or gonna import a shapefile. The same shapefile that we worked in the last section, I'm gonna input it here. So what we do, we're gonna have to click here, map, and then add data. If you click here, we can see a lot of different data that we can input or we can add. So points from table, geocode, extract locations, carry, bounds from path, multidimensional trajectory. Usually we just click here and then it opens your files, your folders. Now, let me go. I don't remember the name. I think it's spatial analysis. Yeah, session 3. So I'm gonna put the alcohol abuse hospitalization shapefile. So you can see here .shp. And once I click it, automatically goes to where it belongs in the map because it will convert or reproject the CRS and the projection itself. So here I have it. Is the same one that we had in the QGIS. The same thing, nothing different. I can put this here so we can see that without the borders and everything like that. So as you can see here, there's a lot of different things that we can do. There's a lot of different paths that we can choose. Let's go one by one. So the first thing is, I just put this shape here so we can see what we can actually do. But in the map, when we click here, we can choose a lot of different things. So we can choose a base map, just like we had one, the topographic. We can choose the navigation, the streets, dark gray canvas, oceans. There's a lot of different ones that we can choose. It's not something that we usually do. We don't usually change unless it's really required us. Uh, because when we're showing this in a paper or anything like that, it can actually create some noise, and then it's a little bit harder for us to see what's actually happening with the data that we want to show. We can, of course, add another data. We can go to XY. We can explore here, so it shows us what to do with mouse, what click, what not click. I can fix zoom in, zoom out. I can go to full extent. I can just go back. I can add data from path. So from where I'm currently using as my workstation. From points, graphic layers, I can select a rectangle or as a polygon, lasso, circle, line, trace. So I can select something like this or something like this. And just, yeah. I can select by attributes. So I want a new selection that is related to the rates, and the rate is equal to 0. And then I'm gonna apply. So it selects all the places that has 0 as the rate. So I can select just by this. I can export selection. Once it's selected, I can just create a different shapefile. I can create a different symbology. I can do a lot of different things. So I can just clear. I can look the attributes. So make a selection. One or more features. I can just put it here and then it will show me what is going on. So this one is the city called Bom Sucesso. It has a rate of 44, almost 45. So this allows me to show all the attributes. And here you can see that there's like a floating panel. I want to close just the attributes, so I'm going to close this one because I don't want it to be shown all the time. I'm going to clear it again. We can explore. I can measure a distance, an area, features. I can search for different things. I can compare selected features. So I need to select two or more, of course, but I can then compare like this one and this one, and then I click to compare. I can pause labeling, I can convert, I can download a map. I can insert new maps. So if I click at a new map, it create a different one here. See? So I can create a new global scene. Just a little bit. So a global scene is a 3D of the globe. And you can see here that we can do a lot of things here with the 3D one. We can remove elevations. We can stick with the topographic one. Let me close it. We can create a new local scene. That is also 3D, or it can be, of course. That we can move it around. We can do a lot of different things here. Not gonna show you everything that we can do, because it's not the goal. We have the stereo that we don't usually use. It's very different. And we can open a new base map. So you don't see anything because I don't have it actually downloaded here. But as I move, you can see there's something here that is moving. Because I'm moving the terrain, the elevation of the road, but I don't have anything to show what's actually happening. So let's stick with this one for now. For new layout, this is where we can create the images that we want to save. We choose the format that we want, so architectural, ISO, portrait, legal, tabloid, A4, A3. We can custom page size. We can import layout file. There's a lot of different things that we can do. We can create a new report, a new presentation, a new notebook. We have a lot of different toolboxes that we're going to show you in a little bit. We can import a map. We can import a layout. We can put some tasks. We can use databases. So we can connect this to online providers. So we can put a server, a cloud store, statistical data collection. We can have some layer templates. There's a lot of different things that we can do. Then the most important one for us, the analysis. So this is where we can perform all the analysis we want. So for this one, let's click on Tools. As you can see here, it opened in this geoprocessing, this panel. There's a lot of different things that we can do. Project favorites, so the most used. Recents, select layer by attribute, the one that I used. But toolboxes, there's a lot of different things. Like a lot of different things. And each and every single one of them has like other features inside of them. So there's a lot of different things that we can do here. The ones that we use most are the spatial analysis tools. So this is where we can put different things on the shape, and the spatial statistics tools. So I can analyze patterns. I can assess sensitivity, mapping clusters. I can measure geographic distribution. I can model spatial relationships. So here we have like different types of regressions or correlation models. We have utilities, time series smoothing, calculate rates. There's a lot of different things. Yes, Ron, go ahead.
All of these toolboxes already come with the tool, Nathan, or do you need to download specific functions, etc.?
Some of them we do have already. Some of them we need to acquire. So some of them we need to pay more to use. These ones are the basics. But when you pay the student fee, the student license, it comes with a little bit more tools than usual. So I have some of tools that are a little bit different, but those like the spatial statistics tools, those are standard. So because the most basic ones are going to be here. Ones that sometimes not come, it's the network analysis or the geocoding tools. So as you can see here, do you see like this little coin next to the hammer?
Uh-huh.
So it means that we need to pay more. I don't know if you guys saw when I opened my account in the website, there's like 997 something there. This is my coins. So I have more 100 coins that I can spend in the app. So if I want to geocode a table of addresses, because I have the addresses that I want it to be like X, Y, or longitude, latitude points, I need to pay.
Mhm.
So when I
I would think
acquired,
that it's probably using the API for Google or something on behind the scenes, and
it's
those
not
are
the Google
your
one.
API credits. It's not
Yeah, it's
Google?
the API credits. It's the Esri itself because they have like
Oh, okay.
their own. There are other ways to
Mhm.
put it to do this for free on R. I never try it. I need to because it's it's very useful. But they're not very accurate as rewind. So this is using the ArcGIS World Geocoding Service, as you can see here in the balloon. And it's very, very accurate. But it's very expensive. So only if you really need like a lot of this. But we have like Geo AI tools as well we can use. There's a lot of different things that we can put here to try to create different type of patterns or statistics. So this is the most useful ones. We have, of course, a lot of different things. We have possibilities of joining, just the same thing that we did in the QGIS is a little bit different, the vision, but it's kind of the same at the same time. So I have the input table, which ones that I want to input. I need to select a join table. I don't have any here to show you. I can validate before uh, agree to it. The only thing here is that I cannot select which ones I'm including in the join. So with the QGIS, I can choose, I want this one, and this one's variables only. From 100, I want 3. This one will join the 100, and you cannot select only the 3 when you put in the joining. We can summarize statistics. We can show the attribute table, and it's going to be here. So same things apply. The same thing as the other one. The difference is it's not going to be like a pop-up table. It's going to be here. So you can see everything all at once. As you can see here, there's some errors in its reading because it has some accents and symbols that ArcGIS does not recognize. So this is something to be mindful of because it's important to have everything as close as optimal as possible. But let's talk about symbology. I want to do the same thing that I did with QGIS, that is create a rate for this map and show it. So we go here, we click with the right button of the mouse, and then we go to symbology, and it comes here in the right panel. There's a lot of different things that it's different from the QGIS. I can use single symbol, that's the standard. I can use unique values, graduated colors, bivariate colors, unclassed colors, graduate symbols, proportionate symbols, dot density, charts, and I can use based on a dictionary, which is very useful when you have like a dictionary that you don't want to, that data set that you want to create a rule, and then this rule will automatically create the symbology. So let's go for graduated colors. So it gets the first variable, and this ugly colors. We can change the field. Let's put the rate. So it's a little bit more consistent what we want. We can do some normalization. So we can put log, we can do percentage of total, or we can normalize by other variables. This is very useful when you need to normalize something that are really skewed or something like that, or you have a lot of zeros. The method, as you can see here, it's natural breaks, Jenks natural breaks. It's a standard, so ArcGIS will use the standard ones. But we can use quantile, equal interval, we can define an interval, we can do manual interval, geometric, and standard deviation. All of them is going to be different, so if I choose quantile, changes the appearance of the map. Equal intervals, again. Defined intervals, I will define the size of the intervals. I can create a manual one, so I just click here and change the numbers. The geometric one, and the standard deviation. So this is how we can lie with the maps. Because once we choose which ones we want to show, it changes our perspective. So if I go to geometric, it feels like a lot. Like, what's happening here? There's a lot of municipalities with hospitalizations. But with go to natural breaks, is the opposite. Why? Because we're changing the values in the legend, so it creates different types of metrics that we can use to just show any data that we want. And this is where the problem came, because we can lie with these data. So again, usually we go for natural breaks, or quantiles are the most used ones, or we can do manual intervals. If we have more than one map that we want to compare, like, okay, I have 2023, 2024, 2025, and 2026. And I want them to be in the same parameters, because of course they're going to be different. Then I need to create a manual interval to be able to compare them. That's important too. I can change the classes up to 32. Not very useful, because who wants 32 classes? Not useful at all. And we can change the colors. Thank God, because this one is really annoying. This is better. And one thing that is good in this one is that when you click in view, we have the color vision simulator. So if you click here, we have deuteranotopia, pronotopia, trinotopia, and achromatospia. So these are different types of colorblind visions. So this one is to simulate green blind vision. So this is how someone that is green blind sees. We can choose the red blind. Is this one. The blue blind is this one. And then the full color blind is this one. So here we can choose which one is better. And if it's people with color blindness can actually see what's happening, because we don't want something that is not going to be useful. Most of the color schemes that are standard here, it's going to be good to be seen by colorblind people. But some of them can be really confusing, as this one is not the best. Or this one is kind of not that great. And this is the basic one, so really ugly. So we can choose different types of colors here, and I like this tool that allows us to see if it's good for people with color blindness. Okay, so this one is how we can put the rates here, just like we did in the last one. Of course, this one is the basic rate. We didn't put the smooth version of it like we did on Geoda. So let's create a smoothed rate that we can then perform some analysis. To create a smooth rate, we go to geoprocessing, and then we can just type here rate and calculate rates. This calculate rates here, once it opens, yes, yeah, not. You don't need to open if you don't want. Anytime soon. So this calculate rates, we can actually calculate the rates that we want and different types of rates, just like we saw on Geoda. Or not. Perhaps we don't want to. Let's see if this way here goes. Spatial Analysis tools. Measuring. It's not measuring. It's not analyzing patterns. Mapping clusters. Assessing sensitivity. Calculate rates. Sometimes when you type it in, it just doesn't open. I don't know why, but it just happens. So let's put here alcohol abuse hospitalizations. So I want to create a one that is going to be, I created the rate for 23, I wanted 24, and population 24. And I want to another one that's going to be 25 and 25. And this is very useful because we can create all at once. We don't need to just, oh, yes. We don't need to create every single one by one. And I want to create as well, no, all these ones. And then I can create a crude rate, a global empirical bias, a local empirical bias, a locally weighted average, and a locally weighted median. So let's put here local empirical base. The distribution, I want Poisson. I want contiguity edge corners, which is the same as queen. So contiguity edges is rook, contiguity edges is corners is queen. And then rate multiplier, I want 100,000. So these ones append fields to input. I think this one is the one that I want to. Yeah, I'm gonna put this one here. One thing that I like about ArcGIS is that we can run or we can schedule. So I can schedule like, okay, do this in half an hour, do this in 1 hour, do this in 2 days, and we will do. We can reset parameters, and we can, of course, use the Python command. Let's run it right now. So there's some warnings. Some of them could not be calculated for some reason. That's okay. We can see, oops. The details here. So there's a couple of warnings. The rates could not be calculated for 4 out of the 399. Fine. Rate 1, that is 2024, it creates the minimum crude rate, 0, the maximum, the median, the mean, the standard deviation, and the local empirical base rate. So the minimum is not 0, it's 1. And then summary of neighbors counts. And then R2 is the same. And if we open the attribute table, it's right here. So we have the rate 1, that is spatial local empirical base, and then rate 1 CR, that is the crude rate. It creates both of them. So it's the same thing that we did on 23, but now with 24 and 25. And one thing that I like to do when I do this is try to compare both of them. And one thing that is really useful for us to compare is when we go to symbology. And then instead of graduated colors, we go to bivariate colors. So what does bivariate do? It creates a bivariate map. Let's put rate 23 and rate 24. And then what it shows us is a color scheme that is a grid. What does grid means? So the pink one shows rates of 2023, and the blue one shows rates on 2024. So if it's like really, really, really light purple, it means that it's low on both ears. So this low is both ears, this is low in both ears, this one is low in both ears. If it's really dark pink, like this one, it's high on 2023 and low in 2024. If it's blue, like this one, it's high on 2024 and low in 2023. And these ones are the ones that is high on both of them. So this is a grid that is really interesting to see because it shows us we can compare two different rates or two different variables. And we can change that to 2023 and 2024. Or we can put 2024 and 2025. And it's going to be a lot of different color schemes. So I think it's useful to see if you want to do like a temporal analysis to see the patterns, the temporal patterns, where the differences are. So there's a lot of differences here that we want to acknowledge between all of the years. And we can change the grid size. So we have 2 by 2, 3 by 3, that is the standard and the most useful one, and then 4 by 4. Let's go back to graduated colors. And then I'm going to put here the rates for 2024. Change this terrible color. Let's put it a green blue. Yes. And then with this one, this is the crude one, right? Memorize it. And then we're going to go to the smoothed version of it. Error. Okay, so it's not showing us because of some error with the rate. As you can see here, there's a minus, so something wrong occurred, we would need to see on the attribute table, and then we go all the way here. And here we go with 0, 0, 0. Let's change it back here and then R1. As you can see here, now there's the smoothed version. It's really important to check the data once you do it. So this smooth version here it reminds us of the one that we did on the Geoda. Of course, this is another year, so that's why it's different. But as you can see here, it's more clustered already. So this is the smooth version. This is the crude version. As you can see, there's like more random cities, more random colors than this one that is more like together. It's clusterized. The same goes for R2. Let's just move this here and remove this one and put 0, so we won't impact on our analysis. And then R2, again, the different types of maps. So this is how you do basic mapping on the ArcGIS. Is the most useful software that we can have. We can do the same thing that we did on the other one, and this one is a little bit easier, so we can apply it to fill an outline, and it's gonna be prettier, and we can just input another map on top of it to create just the shape of Paraná state, because it's easier for us to check on this way when we're trying to understand spatial patterns, because then we see that all the patterns here are just like one instead of just to outline and figure outline, yeah. Because if we put the borders, the small cities can create some noise on our understanding, so it's useful to do this thing. So let me see if I can put the chat back on, because I kind of removed it. Okay, so I'm seeing here that Ashley put it a question about point and click to build maps. If there's like a code, yes, there are codes running it. Specifically, ArcGIS works on Python, and you can do everything on Python if you want. It's a little bit different from what we are used to,
Yeah.
because the Python is really complicated, because it's a little bit different than the standard Python. So it's Python applied to ArcGIS. So there's some things that are a little bit different. Most of it is the same, but it's a little bit different how you
So
create
the
syntax.
the heart of my question is, even if we're not expert at Python, when you've done the point and click, can you export code so that you could rerun it with updated data sets or share it, in cases where we're required to share for reproducibility? Is that a possibility to export when
Yes,
you've
it
done the
is.
point?
Yeah, so let's click here. I do remember there's something like history. Let me just remind where it is. Portal, open history, yeah. So let's go to calculate rates. We can pop out. We have different environments, parameters, and there's, I don't remember where it is right now. I thought it was here. But there's a place where we can like choose, export the code to like send it. Usually when you use ArcGIS, you're not required to send the Python codes. We usually only do that when we want to solve this on an external software or an external view, like Panda or something like that we want to use to run Python. But if we're gonna publish some paper and you say, okay, I use ArcGIS, what they may ask is for the license number, so they can check if it's real or if it's like a cracked version, let's say like this. So you did not pay, so they usually don't accept when it's not paid. So here, Python window. So I can enter the Python here, and then I'm gonna start to do everything that I need in Python. And I can create tasks. I can create everything that I want and then just export it. And there's also help for the Python ones, the Python window. So that's what I want to show today because it's almost cap time. Anyone has any questions?
Some
Comments?
presentation, Nathan.
Joe?
I know that you're gonna touch on a few more methods on the next sections, but
Yes.
so far you've shown us a few different softwares. Can you speak to how you would decide or how would you start if someone wants to start trying out? Should they go straight to ArcGIS if they have the license?
No.
What do you think they should do?
Start with QGIS. Understand the core basics of spatial analysis with QGIS because it's more basic. Of course, ArcGIS is more useful. There's a lot of different things, and once you learn it perfect, you know everything that you need to do. It's amazing. But ArcGIS also relies on the license and a more advanced knowledge than QGIS. QGIS, it's easier for us to start learning what we want to do. So like the joining, it's easier for us to join in QGIS than it is in ArcGIS. For example, on QGIS, I didn't have any problems joining the different variables between the shapefile and the CSV. Here, I would have a problem because if I try to do this with the CSV, it probably won't work because they don't accept, because we need them to reproject as a table within the project on ArcGIS. So I think that if you want to understand everything from the basics, QGIS, learn it, start to use it with the other softwares like Geoda, and then you move to ArcGIS. Because then you have a pretty good knowledge on how spatial analysis work, and then you can go to more advanced ones. Because this is it's not easy as QGIS. It's not as intuitive. It is intuitive, but it's not as intuitive as QGIS. So start with QGIS. And it's free, so it's more useful. So next week, I'm going to talk about geoprocessing toolbox, which is what I already showed you a little bit. And then I'm going to show you what the process is and this actual analysis that we can do. I'm going to use ArcGIS, and then I'll probably show how you can do this in QGIS at the same time. because then we can compare and see if there's a possibility or not, and which ones are exclusive, because there are some that are exclusive to ArcGIS.
Awesome. Perfect. That would be really helpful to understand which to choose in the process. Thank you.
Yes. Any
Any
more
other questions to Nathan?
Am I going too fast, or is it good to understand? Okay. Sometimes I just get too excited, and then I just go as like, okay, you already know this, and then you don't.
Yeah, I think you're doing great, Natan. In terms of the pace, I'm counting on going back and looking at the recordings. I don't know about others, because for those of us that are beginners, it is hard to follow step by step, but I think that's
That's
fine. That's why we can go back and have the recordings. So as I shared in the chat, in case you guys missed it, there's a playlist. This one will be added to it of all the previous videos and this one. Feel free to share with anyone you like or go back on your own if you want to follow along and try step by step.
And reach me out if you have any doubts. Promise a response in 2 working days.
Oh, wow. You heard it here, folks.
Okay, thank you so
Okay.
much.
Thank you for coming, Nathan. Thank you for the great presentation. We see everyone next week, hopefully.